Hello and welcome to this lesson in quantitative reasoning. This is part 2 of 2, where we look at two set Venn diagrams in complements, intersections, and unions. In the first part, we looked at complements and intersections, and in part 2 here, we're going to look at unions. Talk about what the union of a set is, what the symbol is for it, and what it looks like on a Venn diagram. So suppose a school is holding a pep rally. When I taught high school, every Thanksgiving there was a pep rally. Kind of wasn't my thing, but a lot of people got into it. Anyway, you're supposed to show your school spirit, okay? Every student attending is either wearing a blue shirt or a blue hat to demonstrate their school spirit. In my school, it was orange, so I had lots of orange clothes. But anyway, so every student there is wearing either a blue shirt or a blue hat. We could write down the names of all the students wearing a blue hat and the names of all the students wearing a blue shirt on separate lists. Now, any student who has both a blue hat and a blue shirt will be written on both lists. Okay, so that would be the intersection, the students wearing both a blue hat and a blue shirt. That would be the intersection. So that's the intersection. The union would be all of the students who had either one or the other or both on, which they're saying every student at the pep rally is wearing blue. That reality never happens, but all of the students wearing either a blue hat or a blue shirt, even if they have both on, are in what we call the union. The union of two sets is always a larger set, or equal to one of the sets if the other set is empty. Union is large, okay? It's large. The intersection is smaller. It's more constrained. It has to be in both sets. The criteria is more difficult. Union, fortunately, the symbol for that is a big U. So union, when things are in union, they're joined together. You join everything together. When things intersect, they overlap. The intersection of two streets is where the streets cross each other. So union is larger, intersection is typically smaller. So the union would be all of the students. Set A could be the ones wearing a blue shirt. Set B could be the ones wearing a blue hat. A intersect B would be those students wearing both a blue hat and a blue shirt. A little review from last video. So, set contains all of the elements in either A or B or both. Now remember, we could have a whole list of elements in A. So I'm going to make up a set A. 1, 2, 3. And make up another set B. 3. Oh, that's a 2. I'll leave it at 2 then. 2, 4, 6. So the union would be all of them together. So I can start by writing one of the sets. I'm just going to write set A because everything in set A is definitely in the union. And I go to set B. Now, I have the number 2. I don't typically write that again. Remember, in sets, you only write the element once. So, I would write a 2, but it's already there. So I need the 4 is not there yet, and the 6 is not there. So this would be the union. Now, what we talked about in the last slide was the intersection. That would just be the elements that are common to both, which is just the 2. And some interesting things come out of this. So look, that the union, just because there's 3 elements, the cardinal number of A is 3 and the cardinal number of B is 3, I don't get 6 elements in A union B. I get 5 elements. And that is because there is one element in common. So the size, and that's we can write the size like this, or the size of A union B, or the cardinal number of A union B. Either way, it means the same thing, is the size of A plus the size of B minus the size of the intersection. So you can't just, if you asked about the size of the union of two sets, it's not just adding the elements together. You have to know something about how many are in the intersection. But this is the union. You just write down everything that you see listed in either set. And the ones that are listed in both, you just list them once because in sets we don't repeat elements. It is not necessary. This isn't, in statistics, it would be important to repeat that too. But in this class for a set, if you're talking about data, yes, the 2 is important. But if you're just talking about things in the set, the repeat is not important. So let's consider these 2 sets again. Orange, purple, green, red, orange, yellow. A in union with B. So I typically would start by writing, I know the answer's below, but I think it's helpful if I explain everything in A. Then I look at B, because I got to make sure I cover everything. Okay, I haven't written red yet. Orange, I already have orange. I have not written yellow yet. So this would be another case where our original individual sets had 3 elements each, but the union only has 5 because there's 1 in the intersection. Because if you just added set A and set B, you get 6 elements, but you've counted orange twice. That's why you have to subtract off how many in the intersection to find out how many are in the union. Okay, we only list orange once. That would be the important part there. And finally, another example. So on a Venn diagram, the other thing I wanted to point out that I haven't pointed out yet, if this is your universal set in the rectangle, and you're not given any numbers, you're just given 2 circles and said, show A union B. What you're going to do is shade the area. So you want to show the area that represents all A in union with B. You're going to shade everything inside, including the intersection, both circles. So this represents A union B. Now, if I got really fancy and I said, now, if I was actually looking for A union B complement, the white part, the outside part here, is the complement of A union B. You would find if I had this situation here, I would find A union B first and then everything outside of that. I can't use the analogy of developing film and having a negative because nobody knows what that is anymore, but that's basically what we do when you talk about complement. So the other thing I wanted to show you about Venn diagrams to remind you of, and I'm going to erase all of this, is what if I want to shade in the area that's A intersect B? That's the intersection, the overlap, the area I would shade then would just be this egg shape here. The intersections of 2 sets are always this kind of oval shape. Even when we get to 3 sets, the intersection of 2 of the 3 sets is still this full oval shape. So I would shade that basically. I'm not doing too good a job getting near the edges there, but maybe that's a little better. So that's what A intersect B. Even if I have no elements, I don't know anything, I just have 2 circles. If I ask you to shade A intersect B, you can do it without knowing anything else about the sets. If I ask you to shade A union B, you can do it without knowing anything else about the sets. So let's go back to the question at hand here, which does have some sets they've given us. I want to erase that. So we have A is 5, 6, 8, 3. B is 3, 6, 9, 2. And I want to find A union B. First, I want to draw a Venn diagram. And let's review how we draw the Venn diagram. We find the elements in common. It looks like I have a 6 in both sets, and I have a 3 in both sets. So I put those in the intersection. I write the 3, I write the 6 in this overlapping space. Now, for set A, I know the 5 has to go outside of the overlapping space because it's only an A, so I write the 5 here. And the same for the 8. And then the rest of B, I have a 9 and a 2, and they go, and there's your 9, there's your 2. So that's your Venn diagram. A union B will be everything you see written inside any of the 2 circles, anywhere in any of the 2 circles. So A union B comes out to be this set, 5, 8, 3, 6, 9, 2. Now, some students get really irritated when I don't write things in order, but you don't have to. That's emphasizing this. Let's count how many elements are in the union. 1, 2, 3, 4, 5, 6. Well, the cardinal number of A, and I think your book uses this n of A, other books use the absolute value, is 4. The cardinal number of B, just how many elements are in the set, is 4. If I add those together, I get 8. But how many are in the union? The cardinal number of the intersection. The cardinal number of the intersection was 2. So what you notice is the 4 plus the 4 minus the 2 gives you the 6 that is in the union. The cardinal number of the union of the sets is 6. So those are a couple of other interesting things that this PowerPoint didn't point out that I wanted to point out for future reference for you. Please let me know if you have questions, and I will see you in class.